Hi there, Turgeon here, bringing you physics from afar. Molten metal, melting ice, evaporating water, boiling water, condensation. These are all phase changes or changes of state. What's going on here? Are things being heated up? What's happening with the molecules? Could you boil iron? We're going to think about heat, temperature, and the energy of the molecules during phase changes. Let's take a look at a demo. I think I might have shown you this, and if I haven't, remind me. You got two ice cubes and something interesting happens. I'm not going to give it away, but that is an introduction to two topics. One of them is phase changes. One of them is something called means of heat transfer. Now, I'll give you a hint. There's going to be some melting going on. Let's sketch a graph of a phase change happening for water. More specifically, it's going to go from ice to steam. In a phase change graph, what I want you to understand is it has temperature on the y-axis and it has heat on the x-axis. That means heat will increase and temperature will increase. 0 and 100 should look familiar as temperatures related to water. Now, obviously, as you heat something up, it raises its temperature. So you're heating up this ice and it's going, you notice it started below 0, it's going towards 0. Of course it is. When you heat things, they increase their temperature. But something weird happens. As you keep heating the ice and you start to change it over to water, you start to notice it melts. Its temperature stabilizes. What's going on here? I thought that when you heat something up, it changes its temperature. We even have an equation for that, Q equals mc delta T. Something's going on here. Then what happens is, during this process, once all the ice melts, now you've just got really cold water. And once you've got all cold water, it will start to increase its temperature again. Notice that this plateau matches the 0 degrees Celsius point. Notice that the next plateau, yeah, you guessed it, once you get all the water ready to boil, the water doesn't start boiling instantly. You got to get it up to 100 degrees Celsius and then it will start to boil. And this represents like a pot on the stove with a nice rolling boil, and it will eject all those molecules into the air, which we see as steam, and it will maintain its 100 degrees Celsius temperature. If we could somehow capture all that steam, which is not realistic in your kitchen, don't try to do that. If we could capture all that, we would get like a pressure cooker, and now all of a sudden the steam would then be able to raise its temperature even further. Now these are the 5 segments of a phase change graph. This is probably the most important aspect of phase changes and of my objective for you. Let's identify what each of these different segments are. I'll often call these segments. Somewhere in here there's a solid, somewhere in here there's a liquid, somewhere in here there's a gas. And then there's these processes of the solid is melting and the liquid is boiling. So let's figure this out. Well, I said before this was ice. So this is a solid. That makes sense. But it's a solid that's increasing its temperature. Then I said over here that between 0 and 100 degrees Celsius, it makes sense. That's from freezing to boiling. That's a liquid. This is, of course, the gas when I refer to the steam coming off of the pot. Now, solid melting. Well, I said this was the ice and this was liquid, so this is a transition. You might want to write in your notes down here. This is a transition. And as usual, pause the video if I'm talking too fast. Just pause. This is the liquid boiling. So this is, imagine the pot on the stove and it's actively, you're watching this convert over to gas, and you literally, if you forget about a pot, don't do this, it's dangerous. You forget about a pot, you go do something else and the water's boiling, or like you're cooking some soup or something, and you walk away, you'll notice that the water level actually goes down, so you have less liquid. And you might also notice that the windows are fogging up because you've created a lot of steam. Phase changes happen because we're changing the state from solid to liquid to gas, or the other way around. So heat has to flow either into or out of it. If you're freezing something, heat flows out of it. If you're melting something, heat flows into it. First, the heat has to change the temperature to get ready to boil. What that does is increase the kinetic energy of the molecules. Then it has to change the phase. That would be the plateau, but then that increases the potential energy of the molecules. Picture two magnets that are stuck together. As you pull them apart, you're increasing the potential energy. They're getting further away from each other. If they were floating in space, you let them go, they would slam back together slowly at first. But they have more potential energy when you pull them apart. That's what you're doing with molecules when you add heat during the phase change. We're not talking about a room temperature bit of water that you're heating up here. Then when you change the temperature, yeah, we're not going to get into this too much. Yeah, we'll just stop there. Not going to worry about that. That's the most important part. So what do I want you to be able to do? Well, here's an example. I want to be able to give you a description like this and tell you to graph I'm just calling it mark the points for now. You'll see what I mean in a second. The beginning and ending points. So check this out. So first you make your graph. And you have to be able to label the axes, and this would be wrong. Like if you put this 0 down here, I want you to line up those plateaus. And now we're going to build this graph. So the beginning and ending points. Okay, it says it starts at -80. Well, I need to put this point on the graph somewhere below 0, but it can't be hovering down here. It's still on this graph. So somewhere around there is -80. And then it says it rises, it boils away completely. Okay, so it's got to be above the boiling temperature of 100, but it boils away completely, but it doesn't mention it gets any hotter than 100. So I just got to stop there. If I go like this, watch this. This is really important. If I go across this graph with this point, that represents the water boiling away. This is the water, half of the water boiled away. This is the water completely boiled away. That part, kids really struggle with that. Write that down. Like that's hard to understand. So I can fill in all these, and I'm putting like emphasis on this graph. I'm like filling these in more emphasis here. These are darker. I'm highlighting these 4 segments. 1, 2, 3, 4 segments. It never gets on this segment at all. That's kind of in the background. This is interesting because this is an actual graph of water boiling that Mr. Riley got a few years ago, and it took him a lot of tries because he had to start out with the boil. He had to actually create a test tube type situation. It's complicated, but that's real data of this happening. There's a really good video I want to show you, which shows the molecules. I'll do that sometime. So what did we learn? We learned that the heat flows, but it does something different than raising the temperature. If the heat flows into the object, that's different from the heat flowing out of the object. The heat flows into the object, it moves up the cycle from melting to boiling. If it goes the other way, it condenses and then it freezes. The temperature does go up, but not always. During a phase change, it doesn't change, which is crazy. The temperature does not change. And the energy in the molecules, well, when you're increasing the temperature, the kinetic energy increases, but when you're changing the phase, the potential energy increases. This has been Physics from Afar. Sorry, I just want to add 10 more seconds to this. I do want you to write this down. So I decided I wanted to talk a little bit more about the temperature. When you change the phase, yes, if there was a temperature change and we wanted to calculate that, during the segments where it's not actively changing phase, the temperature does change. But while it's actively changing the phase, heat is still added, but the temperature does not change. That's really important. For example, if you have ice that is melting, it stays at 0 degrees Celsius during the entire melting process. This has been Physics from Afar, for real this time.